demonstration on Autodock. Autodock is used to get the interaction between protein and ligand mainly, and in this demonstration we will cover two aspects. One is rigid docking and another is virtual screening in structure based drug design. In the rigid docking, first you install Autodock. You can go to the Autodock website and you can follow the procedures to install Autodock, and here we require a protein as well as a ligand. In the example we use the protein ABL kinase and the ligand imatinib. We will get the PDB structure of this ABL kinase from the protein data bank. Here the ID is 1 IEP, and the ligand information from any of the small molecule databases like Zinc database or the PubChem and so on. So, then we get different orientations for this ligand, and you try to get the best complex between the protein ABL kinase and the ligand using interaction energy as well as the clustering histogram. In the case of screening, we get several ligands. So, we need to identify which ligand is the best to interact with this particular target. Here the target is the ABL kinase. So, we have several ligands. You can obtain all these ligands from Zinc database, and you screen all these ligands with the target, that is ABL kinase protein, and find the best ligand based on the interactions, right, and then we tabulate all the interactions, and based on the interactions you can identify the best one which interact effectively with this ABL kinase. The workflow includes first the preparation of the ligand and prepared protein. I discussed the details in earlier classes, and we set up the grid for the interactions, and finally we need to do the docking and to get the score between protein as well as the ligand. Now, we watch the detailed procedure to get the complex as well as how to get the score and how to identify the best ligand among the pool of different ligands obtained from the Zinc database.
In this session, we will see how to do docking using Autodock. In order to get the protein structure, here we are going to use PDB database. Our interest of the protein is ABL kinase. So, go to PDB database and then give the PDB ID 1 IEP and download the PDB format. So, if you install PyMol, then click 1IEP structure. So, this particular protein structure has two different chains, A and B chains, as you see here. In our docking experiment, we are going to consider any of the one of the chain for the docking purpose. So, in this we have to select molecule, so select any one chain. So that will be like SELE. So save them as a separate object, copy to object. So that will be OBAJ02. Now you can save this file, save molecule. OBJ02. So now you can save them kinase in a PDB format. So once you retrieve the protein, then you have to retrieve the ligand. Then go to zinc database, then type in search, go to search option and then click on text and then give the imatinib. And then click enter. Then you will get to this, you will navigate to this page which includes the structure of the imatinib and then the various properties of this ligand. We have to download this structure in the format of mol2. So click mol2. So once you downloaded the structure, protein and ligand structure is ready for the docking. So you have to open the Autodock GUI. Click, first you have to prepare the ligand. So click on ligand, go to input, open. Whatever you have downloaded, the imatinib structure, you have to input here. So this is the ID zinc 19632-618. It is in the mol2 format. So just open this. So this is giving you the information about this ligand, which consists of 29 nonpolar hydrogen atoms and 21 aromatic carbons and 8 rotatable bonds. So click OK. So this is the structure of your interest. Now go to ligand, torsion tree, detect the root. This helps you to identify the rotatable bonds in your ligand. So go to ligand again, torsion tree, choose torsions. So in this we can identify how many bonds are rotatable in the in the given ligand. So in this we can see 7 bonds are rotatable out of 32 bonds. So there is a amide bond in the given ligand. Now we are allowing them also rotatable. So make amide bond rotatable and click done. Go to ligand, output, save as PDB-QT. So we have to save ligand and the protein in the PDB-QT format for the docking purpose. So Q stands for the charge, T is the atom type which is specified by the Autodock. So save as PDB-QT. So I have saved the ligand now. Now we have to prepare the protein. Go to file, read molecule. So you have only taken any one of the chain from the 1IEP. So open that chain now. Kinase PDB. So this is the 3D structure of the ABL kinase. In this Autodock we can see various display options. L stands for line, B stands for ball and stick, C for coil and R stands for ribbon. So I am going to change the option from lines to ribbon. So this is the 3D structure of ABL kinase. So as we all know, kinase has 2 domains. This is the kinase domain. So we have to prepare the protein first. Go to edit and click on hydrogens, add polar only, give OK. go to edit, atoms, assign AD4 atom type, edit, charges. You have to add charges. You can use two charge options. One is Coleman charges, another one is Gastiger charges. So I am giving here Coleman charges. So Coleman charge will be computed based on the quantum mechanics. So once you have added the charges, then file, save PDBQT, user defined any name, save in your working directory. Now we have prepared the protein and the ligand. The next step, you have to set the grid for the Autodock. So go to grid option, click on macromolecule, open. So open this kinase PDBQT which you have prepared currently. Want to preserve the charges. So this is the structure. Then you have to open the ligand. Go to grid box. So here we are going to set up the grid for Autodock, where you are allowing the ligand to do the conformation search in this specified space. So if you know the binding site, then you can specify the binding site area. If you don't know the binding site information, then you can set the whole protein in a grid so that it will do a blind docking. So in this case, I know in the kinase protein we know the binding site, so I am going to give the grid box in the specified area. So go to center, center on macromolecule, then adjust the grid box such that it will cover only this portion. So you can increase the XYZ dimensions. So that it will cover this space. Go to file, close saving current, go to grid output, save as a GPF file format. This is grid parameter file. You have to save with the GPF extension. Then you have to run the AutoGrid. Run AutoGrid. Specify the executable and specify your grid parameter file, and then click launch. It will take some time, 5 to 10 minutes, to finish the calculation. Usually this grid helps you to identify the interactions between the atom types. So once you finish the grid, we will move on how to do docking. So already I am having the output file for the grid. So after grid, it will create the GLG file for the grid. So this GLG file will be having the information about the different map type, different atom types along with its interactions. So this will create different map types based on the atoms that you can see here, kinase dot A, C, D, E, H, T maps. So these are the some of the map file, nothing but these are the interaction mapping of the different atom types in the given specified grid. So once you finish this, go to docking, macromolecule, set rigid name, because in this case we are going to keep protein as a rigid particle, and then we are allowing the ligand to move around in the specified grid box. So open this PDB-QT file. Macromolecule is nothing but your protein. So ligand, open. So this will ask you the options, like how many bonds are rotatable. So here the degrees of freedom is like active torsions in the ligand is 8. So accept this. Again go to docking. Here I am going to use genetic algorithm for doing the conformation search for the ligand in the given grid. So here I am going to mention how many conformations you want. You can change this options, number of GA runs. So here I need 20 different orientations, so I am going to specify 20 and accept this. Go to run. Again other output, Lamarckian GA. You have to save this file in a DPF file format. DPF is nothing but docking parameter file. So you can give any user specified name. With a DPF extension. Once you created the DPF file, you have to run the Autodock. So click run Autodock. You have to specify the Autodock executable file. And then your DPF file. Then click launch. So this will take some moment to generate the various conformers, and then it will create a DLG file. DLG file is nothing but docking log file. So this is the DLG file. So go to analyze, docking. You can open this DLG file from the GUI of the Autodock itself. Open. So this is giving the different conformers of imatinib ligand. This is the docked conformation of the imatinib ligand. Go to analyze again, macromolecule, open. this is your interest of protein, then change into ribbon. Go to analyze, conformations and play. So in this, in the DLG file you can see the different conformations. Using clustering histogram, you can identify which conformation is the best binding conformation for the specified protein. So this is the cluster analysis of the conformation in the DLG file. So you can see here I have generated 30 different conformation for this imatinib. So here we can see minus 10.28 is the best lowest binding energy for the given given ligand, which forms four different conformations will fall in this same energy bindings lowest binding energy. So this is the best conformation for the imatinib. So go to 11th run 11. You can see here the binding free energy is minus 10.28 kcal, and which will be giving you the inhibition constant of 29 nanomolar and various intermolecular energy parameters along with the XYZ coordinates of the given ligand. So this is how the DLG file looks in the after docking. So go to analyze, clustering, show the clusters. So here, as I showed earlier, you can see the four conformation which fall in the category of minus 10 kcal. So you can select this. So there are four different you can see here. Change the ligand style to the lines so that you can see the ligands here. Go to click this option. So you can save this conformation in a PDB QT format or else PDB format. So in order to do that, you have to click this button and then click build current. and then write current. So this is your best docked pose, so you can save as docked pose 1 in a PDB-QT format. So you can open this file in the PyMon. You can visualize the interactions using PyMon. So you can use this option build hydrogen bond, that will also show you the hydrogen bond which is specified between the ligand and protein molecule. Here we can see there is a hydrogen interaction between the methionine and the ligand with this pyridine. Here we can see there are 2 hydrogen bonds. One is with methionine, one is with the aspartic acid. So this amide forms the hydrogen bond, and this carboxyl group also forms a hydrogen bond. So from Autodock itself you can visualize the hydrogen bonds, or else you can open the PyMon and then you can visualize the hydrogen bonds. So here we finished with the rigid docking. Now if you have multiple ligands, then how to do the docking, high throughput docking screening using the Autodock Vina. So in order to do that, you have to install the Autodock Vina. You need 2 files for it. One is configuration file, another one is the PDB-QT of your protein file. You need it for the screening purpose. So I'll show you how to prepare that. So already we have seen there are 8 ligands. You can go to Zinc database, then retrieve the mol2 file format of those ligands. Then you have to prepare the ligands. As I told you earlier, you have to go to Autodock, then prepare the ligand by input, click on input, open, and open the particular mol2 file format, give open, then save, then detect the root and choose torsions and save in a PDB-QT file format. So likewise you have to prepare all the ligands. Once you prepared all the ligand and the PDB-QT of your protein, then you have to do screening. For screening you need this configuration file. So this configuration file will be having the details of the receptor, which is a kinase, in the PDB-QT file format, and then the XYZ of the grid. This detail also you have to specify. This is the grid I have used for the rigid docking. So the exhaustiveness for particular ligand, how many conformer it should generate. If you want to generate more conformer, then you can increase the exhaustiveness by giving like 20 or 30. Here I am changing to 20. Then save this config.txt. Then you have to create screen.bat file. So screen.bat file will be having the information of, we are having different zinc IDs. So we have prepared the PDB-QT file format using the Autodock. Then you have to specify the zinc. So it will take all the zinc IDs which will start with zinc extension. So this script helps you to take the different ligands in the PDB-QT format. Then it will dock with the specified protein structure, and then it will create a separate folders for each ligand along with the different conformers. So likewise it will create like zinc with the extension of the ID. So go to this, once you created screen.bat, go to this specified file, go to the command prompt, so this working directory should contain the detail of the PDB-QT of your protein, the PDB-QT of various ligand, whatever you want to do the screening, and the configuration file and the screen.bat file. So you have to run the screen.bat file. So just type screen.bat and give enter. Once you give enter, so the program will run and it will produce the different folders, starts with zinc along with this ID. So you can open this any one ID, then you can see here out.pdbqt, which will be having the confirmation of the particular ligand. So you can open the Autodock, then click analyze, docking, open Autodock winner result. So it has multiple confirmations, so single molecule with multiple confirmation, give OK. So there are 9 docked confirmation. So you can analyze the interactions using PyMor or else So this is the structure of the ligand. So we can see here with the energy. So the first docked conformer, which will be having minus 9.1, the second pose minus 8.9, third one you can see minus 8.8, minus 8.4, likewise. So if you want to display the interactions, then go to analyze, macromolecule, docking, show interactions. So this shows the binding packet of this particular ligand. So these are the different residues which is in the vicinity of the particular ligand. So you can analyze the interactions using this by clicking this interaction window. So from the different ligand, you have to select which ligand binds with ABL kinase effectively using screening itself. So these are the different types of interaction which will be given from this ligand,